Hello again, everybody. We're going to be talking about Section 4.2, some basic derivative rules. In Section 4.1, we established the idea of the limit definition of the derivative. If you don't recall that, please take some time to review that now. That limit definition is very important and is used in many different ways. But while that limit process gives us a definition for how to find a derivative of a function generally, we notice there's some certain rules of things that happened all the time. For example, what happens when we have a function that is a constant? Well, we can go through and establish this with our limit definition. We can say that, well, anytime we take the limit as h approaches 0, this is the way that we had gone through it, the limit as h approaches 0 of f of x plus h minus f of x divided by h, and f of x is some constant, like, let's pick one. Let's say f of x is equal to pi. There's a good constant, 3.14159. Well, if f of x is equal to pi, then f of x plus h is still equal to pi, right? It doesn't matter what value of x we pick. The y value is always pi in a constant function like this one. So we would be taking the limit as h approaches 0 of pi, which is the value of f of x at x plus h, minus pi, which is the value of f of x at any value x, divided by h, and that's just equal to 0 every single time. And you can see that's the case if we picked any value of x and we looked at the y values that we got. Well, regardless of how we approached x, either from the left or from the right, the y value is always equal to pi, right? Here it is, y equals pi. So regardless of whatever value we choose, the derivative always has a slope of 0. Well, that's just it, right? So this is a nice rule, and it doesn't matter what function we choose now. We can say, well, if I want to take the derivative of the function y equals 7, well, there it is. It's 0. Well, that's one useful rule. There's another set of useful rules that we'll talk about in a moment.